And that's exactly the idea behind using radio waves and radio in general. So let me explain that here. So how does the radio work? There is a radio station, right? And it transmits those waves, radio waves. Right? So what kind of waves are those? Well, those are mathematically of the form A times cosine of m times t. Those are all cosine-like waves or sine-like waves. And the meaning of that A is how loud the sound is. Right? So this is amplitude. And that has nothing to do with the loudness of the sound, right? This is the frequency.
Why is it an M?
Make it omega. Oh, you see, in those computations, I will use these computations. And I never use that m and n are integers. Right? So use omega, its frequency. All right. So, and now I have radio station 1 broadcasting using this frequency quite loudly. Right? And then I have radio station 2. And that broadcasts with amplitude B using frequency, I don't know, delta, gamma. Now, all these waves propagate everywhere, right? All the waves generated in Moscow right now are right here, going through us. At the same time as waves generated in New York and San Francisco, they're all around us and moving at the same time. Now, how do they move at the same time? They add. That's the mathematical modeling of that phenomenon. So, what we get right here at this moment is the signal, which is the sum of these two. A times cosine of omega t plus b times cosine of gamma t. And of course, in reality, it will be sum of all the radio stations, right? Plus sum of all the waves coming from the sun, from the stars, from all kind of things, right? So all the mess is going through us. So let's look at this simple case. We have two radio stations. I add the signals. Now, what happens, and how can we think about mathematically, when you take this receiver, right, and you tune to the given frequency? What does this tuning mean? Well, in mathematical language, when we use the receiver, we project. So we have this signal, which is a sum of those. And we project that signal onto some frequency. And technically that frequency depends on the length of the rod that receives the signal, right? So basically, when you tune, you choose the frequency you want and you project. So in this language, you project either on cosine of omega t or project on cosine of gamma t. Now, what do you want here? Well, what you really want is when you project on this, you get that, right? Because you don't want to listen to Moscow if you tune to New York. And that will be equal to A times cosine of omega t, if what? Well, mathematically speaking, if that independence happens. Right? So if those two vectors are perpendicular, if v is perpendicular to u, then projection of u plus v onto v is simply what? It's v. And clearly it's independent of u, right? And that's what I want there. I want to project onto the first frequency, and I want to get that. And I want it to be independent of all the other radio stations. And that boils down to exactly the statement that cosine of omega t is perpendicular, geometrically speaking, to the cosine of gamma t. And what I was saying there is that this means that cosine of omega t, the dot product in terms of functions, with cosine of gamma t is equal to 0. That's exactly what I want to be able to tune to the radio. And that's exactly what this computation shows. That when I take, in this case, cosine and sine, if one station is using sine and the other cosine, as long as the frequencies are different, I will have the integral equal to 0. And now you see how much flexibility we have in broadcasting, right? As long as these two quantities are just different, you don't have to make them integer, just a little bit different. You can transmit as loud as you want here, as loud as you want there, and anybody can separate those signals. So that's exactly the simple mathematics of integration behind radio. Cool? Just amazing to me. Well, of course, I'm hiding a lot of technicalities, right? I'm not explaining a lot of little things, like why is it that dot product, the way defined, is exactly corresponding to this meaning of projection and exactly corresponds to what I do with when I tune, right? But I mean, there is more physics to come, so I cannot explain everything in 50 minutes.